Well, we have question 5.4 that says consider the identity cos theta over sin theta minus cos 2 theta over sin theta cos theta equal to tan theta. All right, 5.4 and then 5.4.1. What we have, prove the identity. So I'm gonna write here. Okay, we have. I'm gonna write the question first. Okay, over here we have like cos theta over sin theta minus cos 2 theta over sin theta cos theta equal to tan theta. All right, so now to prove an identity is like we're going to sometimes we're going to expand and simplify always in order to prove that the left hand side is equal to the right hand side. Now we're going to use algebra techniques to do so. So now over here, first, okay, the first fraction I keep it the same, okay, because I cannot simplify and not expand here, so I leave it cos theta over sin theta. But on the second fraction, okay, we have like a double angle here, so we can apply the double angle property because we do know that cos of 2a, this is equivalent to cos squared a minus sin squared a, or this is 2 cos squared a minus 1, or 1 minus 2 sin squared a. So we can apply can use one of these formula, like that. So I prefer to take the first one. Okay, so this will be then convert to cos squared a theta minus sin squared theta all over sin theta cos theta. And then tan also, we do know this property that says tan of the angle A, this is equal to sin A over cos Z. Okay, so now over here we will write sin theta over cos theta. Now notice something. The denominator is not the same. Not the same. In order to work out the fraction, we need to make the denominator common. Okay, like here we have like sin theta. That's sin theta cos theta. That's cos theta. They're not common, so we need to make the denominator common. How can I do so? Okay, to do that, we need to find the LCM, okay, of the denominator. The LCM of the denominator, it would be common if it was sin cos, and sin cos. Okay, so now over here, I'm gonna write sin theta, okay, times cos theta. Okay, to make it the same, minus. Okay, the denominator over here is already sin theta times cos theta. So over here we have cos theta. So now I need to make times by sin theta to make common denominator. But remember, at the moment that we times the denominator by a certain quantity, we need to do so for the numerator to make the fraction balance, to make the fraction the same. Okay, over here, because we had cos theta, we must times that cos theta by another cos theta here. The same cos theta we times the denominator. We times by cos theta here, we must times by cos theta there also. And then over here, in this fraction, we did nothing. We didn't change anything, so I will keep the numerator as it was. So that will be cos squared theta minus sin squared theta. And then on the other side, we had initially sin theta but we times the denominator by sine theta, so you must times by the numerator by sine theta also, in order to have the fraction the same, okay? Times here by sine theta. Then we have common denominator, okay? Common denominator. Because of that, we could drop the denominator from here, but I prefer to do it after. So on this side, I will combine these fraction, okay? I combine this fraction. So because they have same denominator on the right, cos theta times cos theta makes cos squared theta. So this will be a cos squared theta, okay? For these two, cos squared theta, and then minus everything here. So now this will become minus cos squared theta. I'm writing that in the same fraction. Now over here, we need to be careful. Okay, I cannot write negative minus sine squared theta because there is a negative sign out there, outside the fraction. So now this negative, okay, change the sign in the numerator here. The reason why this becomes negative, it was positive, then it becomes negative cos squared, and then this would make positive sine squared. So this will become then a positive sine squared theta all over sine theta cos theta, and this is equal to sine squared theta over cos theta times sine theta. Okay, you must notice that if we have like A over B, and then this is equal to C over B, this implies that A equals C. Okay, when the denominator are the same, the numerator are also equal when in case of an equation like this. So we can just drop this denominator. So we have left with the numerator. Now we can also simplify the numerator because cos squared and cos squared, we can cancel them out. So we cancel this one and that one. And then notice we have left with sine squared theta equal to sine squared theta. This is what was supposed to be demonstrated. Quote here and demonstrate them. Thank you. Oh, yes, sometimes we could solve the same problem if we use the second formula here, 2 cos squared A minus 1. We can also use substitute that over here. We'll end up to prove that the identity is to prove the identity. So now let's see. Maybe we should substitute this from here. Okay. So I am going to take the same. Sorry about that. I'm going to take the same. In this line here, I want to change to, I'm going to write it 2 cos squared minus 1. Okay, let's move. Put like this. Okay, and then from here, I am going to move it a little bit. So now over here, I'm going to paste the same identity where we had this. So now over here, we can change this into change this into 2 cos squared theta minus 1. Okay, we'll end up to the same answer. So okay, let's just let's start from the other line because here we may be a little bit behind. So now I want to delete this O. So I'm going to start from the other line over here. I prefer to take this other line. Start from here because we're going to do the same process. Okay. So now let's see. Okay. All right, yes. From here, let perhaps I want to remove this. Instead of using that, I want to use 2 cos squared theta minus 1, right? Now, if we drop the, okay, when we combine the fractions, we will have over here cos squared theta minus 2 cos squared theta minus 1 plus 1. I mean, because minus here and minus there will make positive, all over sin theta cos theta equal to sin squared theta over cos theta sin theta. Now, cos squared minus cos 2 cos squared here will make negative cos squared, okay? That will make negative cos squared theta plus 1 all over sin theta cos theta. Okay, from there, we can just, as I said earlier, we can just drop, we can just cross the denominator, okay? So now this will be equal to sin squared theta. Now notice that negative cos squared plus 1 is the same as 1 minus cos squared theta equal to sin squared theta. And this is even the identity itself, because this is, all this makes sin squared equal to sin squared theta. Proven. Now let's now try if we can substitute, instead of substituting in 2 cos squared theta, we can sub in 1 minus this other 1 minus 2 sin squared and see what will happen. Okay. I'm gonna move this there, and then split my board like this, and we can paste the same step. Over here, I am not going to leave this, but instead I'm going to sub in there 1 minus 2 sin squared theta. Okay, so now this will be cos squared theta minus 1 plus 2 sin squared theta when we combine the fraction. Okay, over sin theta times cos theta, and this is equal to sin squared theta over cos theta sin theta. Now, you notice that this part here, cos squared minus 1, is exactly, okay, is not exactly sin squared, because the property says this. Let me write it here. Sin squared theta plus cos squared theta equal to 1. So if I need to work out sin squared theta, for instance, we change that to the formula. If I need to work out like sin squared theta, I'll say this is equal to 1 minus cos squared theta. But there is, here we have cos squared minus 1. Now what we can do over here, if we do like, if we write like negative there, okay, we can write the same thing like, it's going to be 1 minus cos squared theta. If we place in the negative outside the fraction, outside the brackets here, because when we place it in, it's going to be negative 1, and then negative and negative make positive cos squared. So we can write it like that. And then we have like plus 2 sin squared theta. And then over here, we can also drop the denominator, okay? So this is equal to sin squared theta. Now, all this is just sin squared theta. So we have like a negative sin squared theta plus 2 sin squared theta equal to sin squared theta. Okay? And then negative sin squared theta plus 2 sin squared theta just makes 1 sin squared theta. So which is just 1 sin squared theta. and then this is equal to sine squared theta. So again, the identity is proven. Now, the following question says, let's move the screen there. It says, prove. So we did 5.4.1, and then 5.4.2 says, for which value or values of theta in the interval 0 to 180 degrees will the identity be undefined? All right, let's move. I'm right here, 5.4.2. A big one. So we have like a 5.4.2. So we want the value of theta for which the identity is undefined. Okay. The value or values of theta. Now, the identity itself is cos theta over sin theta minus cos theta, cos 2 theta over sin theta cos theta equal to tan theta. Okay. Then the identity will be undefined if the value at the denominator here, okay, is equal to 0. Okay. Even tan theta, we need to understand that tan theta can be substituted into sine over cos. Okay. It's sine theta over cos theta. So this will be undefined if the denominator here is 0. Actually, we're going to prove cases where sine theta equal to 0. Okay. Sine equal to 0, sine theta equal to 0 if okay, the interval was 0 lesser than theta lesser than 180 degrees. Now, okay, let me write it quickly. The condition here is 0 lesser than theta lesser than 180 degrees. Now, so we know that sin theta is equal to 0 at exactly 0, okay, if theta is 0 or theta is 180 degrees, normally. But now, when you look at these intervals here, okay, the intervals of the inequality, these intervals, lesser than meaning it doesn't reach 0, okay? So neither 180 degrees. So over here, we can say, okay, let me write like this, theta will be equal to 0 degrees or 180 degrees. I prefer to write it like that, so long. Now, for cos theta is equal to 0 if theta equal to 90 degrees. But now this is what I was saying. 0 degrees and 180 degrees are, these parts are not these are not part of the boundaries of are not in the interval. 0 is below the interval, 180 degrees above the interval. But cos theta equal to 0 makes theta equal to 90 degrees. Yes, 90 degrees is in this interval. So to answer this question, we say the solution here is that is just 90 degrees. So we say the value of theta is equal to 90 degrees. If theta is 90 degrees, then the function or the identity is undefined. Thank you.